Good afternoon and welcome to this webinar. The focus today is really focusing on the adoption of VR by the AEC industry. My name is John Mould. I'm the Commercial Development Manager of ST Engineering Anti-Seep. So for those of you who attended our previous webinar entitled VR in AEC, together with our partner BARCO, we walked you through the history of VR technologies as they emerged and as they matured towards professional use cases. We highlighted how VR enabling software tools are currently making it very easy for you to take your CAD datasets straight into your chosen interactive VR display solutions. And we also showed how such displays can be multi-purpose, providing you with a vast pixel real estate supporting multiple applications. So during the last webinar, BARCO provided an overview of their new technologies, such as the Canvas display system that has been created with AEC users at the forefront of their design process. And if you didn't manage to catch this previous webinar, then don't worry, you can still download it from ST Engineering Anti-Seep's website. At ST Engineering Anti-Seep, we're able to propose an amazing array of tailor-made immersive VR solutions to address a wide variety of focuses. Our expertise does not just reside in the domain of VR display hardware, but with over 25 years of software application experience, we bring engineering know-how to provide full solutions. And having established that we have fantastic VR solutions for AEC clients, we wanted to switch our technology focus in this webinar to highlight some of the real-world use cases of those technologies. So following my introduction for the webinar, we wanted to ensure that you hear how VR technologies are being utilized from the people who operate those technologies in the AEC market sector and how it delivers and contributes to their requirements. And after our guest presenters, we'll have our partner BARCO who will bring you an insight to group VR collaboration before we open up to questions to the entire panel. So we're going to begin with Dr. Ardakani from Bath University, who will highlight how the V Simulators offers a cutting-edge facility for human factors research. Dr. Ardakani, over to you.
Thank you so much, John. Good afternoon, everyone. My name is Irfan Shahapur from the University of Bath, and today I'm going to talk about the V Simulators facility in Bath and Exeter with the focus on the Bath facility. I'm going to begin with some rhetorical questions to explain the philosophy of these facilities. So to begin with, why do we have buildings? It's all about buildings. Why do we have buildings? The buildings are basically for people, for them to work, to play, and to live in them. But recent years have seen sustainability as the key driver in the design, mainly through reducing or completely avoiding the depletion of critical resources like energy, land, and raw materials, and also using renewable materials such as timber. But the dichotomy here is that there is no mention of people. I mean, we are designing the buildings for people, but there is no mention of people in this philosophy of design. So what could go wrong? As an example, the combination of inherently low stiffness materials, such as timber, and the increasing demand for tall buildings and slender structures, and also long span open plan office floors, means that deflection and vibrations can dominate the behavior of the structure. So a 2015 iStruck East survey of its members related to vibration issues indicated that basically nearly a quarter of the designers had issues with human comfort on code compliant design, and this is very important, on code compliant designs. And almost half of the participants indicated that they encountered many issues with vibrations during their career. It highlights the significance and the scale of the problem, and this scale is only increasing, basically. So what is an acceptable level of vibrations? We don't really know the answer to this question yet, and probably there is no one answer. As much as guidance and standard writers would like there to be, it depends not only on frequency and amplitude of the vibration, but also on the duration, context, and activities, characteristics of the pupil, and so on. Yet the future design is going to be governed by serviceability requirements, and by serviceability, the characteristics that are really related to the people. So we really need to understand how these factors affect people and how people experience these sort of conditions. This is the question that we Simulators facility at Bath and Exeter is aimed at answering. So the Exeter facility is mainly aimed at simulating higher frequency human or machinery induced floor vibrations. It has low amplitude 6D motion platform, which is instrumented. The Bath facility is what I'm going to focus on for this presentation. It is predominantly aimed at simulating larger amplitude, lower frequency sway movement, predominantly wind-induced motions in tall buildings. But it also provides control of the environment that people experience in a building, all within the context of an immersive virtual environment. We can simulate biaxial and torsional motion, temperature, humidity, light, ventilation, and the surrounding environment and context using the cave type VR system that we have in this facility. Basically, the idea is to simulate as realistically as possible the multi-aspect experience of people in a tall building, including controlling the sensory cues to human, visual, auditory, proprioception, and vestibular systems, and to assess what with very high accuracy their physiological and psychological responses, basically, to these stimuli. So basically answering the questions such as how do humans experience, interact with, and influence the environment they live and work in? What are the acceptable levels of vibration or other environmental factors, and how do they affect each other, actually? For example, how temperature affects the acceptability of vibration, and the other way around. How can we design sustainable buildings where people can be healthy and productive? And also, how can we utilize this understanding to make the human experience more pleasant, healthy, and productive, or in a sense, to use it in a smart way, to use the condition in a smart way to actually increase the health and well-being of the users. So this is the facility at the time of commissioning. So basically, 4 hydraulic actuators move the platform in a horizontal plane, enabling simulation of the building motion in X and Y direction, and also building torsion. Then on top of that platform, we have now an environmentally controlled chamber. Here we can control radiant temperature, air temperature, humidity, light intensity, light, color, temperature, fresh air, acoustics and sound, and so on and so forth. So most of the environmental conditions could be very accurately controlled. To get a sense of the surroundings and give the context, we use a cave type virtual reality system where 3D images are projected onto the wall of the physical room, and with the aid of special glasses we can perceive depth and track, and the tracking provides the perspective to the user. This allows us to represent larger internal spaces, such as this open plan office to represent a workspace, or this apartment to represent a living space. But we can also represent external views, which is particularly important when we are considering the psychological effects of tall building movements. This is, for example, a low-rise city with plenty of green spaces, and this is a dense high-rise city. We can alter both time of the day and height in the building, which radically alters the expectations of the users and the environmental effects they will be subject to. So basically, with this equipment, we can simulate as much as possible what it is like being in a real building, but with the controllability of a laboratory. This will enable both the designers and the client to make informed decisions about the environment and serviceability performance that is required for a particular building, whether that is to establish an acceptable motion performance of a building or the comfortable working environment for building users. But it also allows us to do research on what makes the building suitable for a productive and a healthy community. We can test subjects in the chamber where they will undergo physiological and cognitive tests, which represents, for example, work tasks, but we also can use sensors to measure physiological processes and also the psychological reactions, which may quantitatively indicate various physical and mental states. So I'm going to highlight some of the current and future projects that we are working on at the moment. The first project is looking into the effects of basically vibration on work performance and how work performance is affected under vibratory conditions. The conclusive evidence on how much and under which condition these effects are higher are still missing. Virtual reality in the context of these experiments provide context and environment which is very critical for these experiments to create a realistic environment. So these are some of the results hot out of the oven, basically. So we now have evidence that wind-induced vibrations, even in sub-perceptible range, can reduce cognitive performance. So you can see the 5 milli-G line, the dashed red lines. This is the perception threshold, which means that below 5 milli-G magnitude of acceleration, basically the vibration is not perceptible for the occupants. You can't feel it. But as you can see the drop or the decrease in the performance, in the cognitive performance of the people from these graphs, and you can see the increase in the time that it required to do a task, which again indicates the decrease in their task performance, even below the perception threshold. So it's quite interesting to be able to measure this sort of effects. Also, we have evidence now that the vibration can affect the well-being of people in these conditions, which is quite interesting to quantify that. Another aspect of sway of the building is that low frequency sway of buildings due to wind may cause us to become lethargical and tired. So this is known as soap-white syndrome. Again, this may be just fine at home, and who knows, may improve the quality of sleep, but is less acceptable in the workplace. This then is what we can simulate using the V-simulator facility, and it helps us to understand how motion affects both our comfort and productivity, and what types of motion cause soap-white syndrome to occur. So again, these graphs show the 5 milli-G perception threshold, and it is quite interesting to see that both below and above the perception threshold, the vibratory conditions can create soap-white, which means that even in the condition that we can't perceive the vibration, so we can't understand if it is actually vibrating, it can affect our performance, and also it can create kind of lethargical responses in our body, even without us noticing that, which is quite interesting. So, and these graphs are kind of based on the frequency of the vibration, and again, you can see that for high accelerations, the effects are higher. So we have higher basically soap-white indicators in the case of high accelerations compared to the low acceleration, and also with increasing the frequency in the horizontal axis, we can see that the magnitude of the indicators of the soap-whites are also increasing, which is quite interesting. So basically, current vibration serviceability assessment criteria are based on perception threshold. And this is also founded based on very limited data that is currently available. Here you can see the current curve suggested by ISO guidelines, which is again, you can see that these curves are based on the frequency of the vibration and acceleration, and they are based on the perception threshold. So basically, they say that if you can feel the vibration in a particular frequency and magnitude range, then it is not acceptable. If you can't feel it, it is acceptable. However, these preliminary evidences indicates that this is not right. Basically, perception of emotion is not synonymous with productivity and well-being, so it might not be perceivable, but it could affect seriously productivity and well-being, and it could be the other way around. So it could be perceptible, but it might not affect the acceptability of vibration simply because of the context. For example, in a train, we accept that there will be some level of vibrations, and people work in there and they're happy and they're comfortable in train, although the level of vibration is quite high compared to the building. So it is really context dependent and basically situation dependent. So basically the acceptability and perception are not synonymous. That's the point. Another project that we are working on right now is to understand the effects of virtual reality and multi-sensory cues on chronic pain, and how we can utilize them basically to help people treat and also cope with the pain. The other project is looking at the effects of wind-induced vibrations in tall buildings on balance of vulnerable people, such as older people, and also to investigate the potentials of such vibrations for improving flexibility, bone density, balance, strength, and pulmonary rehabilitation. It is already, I mean, the vibration is already used as a rehabilitation tool, and we want to investigate how useful is the type of the vibration happening in buildings in that kind of application. We are also looking into simulating the experience of a driver and passenger in self-driving cars to see how such handover of responsibility will affect their experience, and how that will affect their basically capability to perform tasks, to read, or to be comfortable in the car. And finally, the final example is basically investigation of how people interact and adapt to the vibration of structure. So this is slightly different from how the vibration affects people. This time we want to see how people are adapting to that sort of vibration. What do they change, for example, in their motion, in their behavior, and how actually they interact with the structural vibrations, such as the case of, for example, the lateral vibration of the Millennium Bridge in London. So finally, I want to thank all the investigators in the vSimulators grant, the vSimulators team, the suppliers who have risen to the challenge of creating this equipment, which was quite complex, and the industry partners, and also the EPSRC for funding the vSimulators projects. Thank you.
And thank you very much, Afan. That was wonderful. I am still really amazed by how innovative the vSimulator solution is. In fact, for STE anti-seep, it was probably the first time we've ever been challenged to take what is effectively a VR cave and with spatial tracking technologies, and to make our system operate on a motion-based platform. So it was a unique project. Our next guest speaker is David Edge from ARUP. ARUP are an independent firm of designers, planners, engineers, architects, and consultants, and they're working upon many of the largest, most challenging construction projects that are in the world today. So, David, over to you.
Wonderful. So yeah, so I'm David Edge. I lead visualization in London at ARUP. And for those who don't know ARUP, it's a multidisciplinary design engineering organization with offices around the world, and with experts covering many facets around the built environment. And it was originally founded by our founder of ARUP, and he had a philosophy of total architecture, where bringing all the experts together with architects and engineers, we get better outcomes. And over the years, we've ARUP's delivered and worked and collaborated with many people, creating amazing kind of buildings and master plans and everything in between. So in the world of visualization, it's broad, and the needs of communicating complexity are heightened around making decisions, but also making projects happen through de-risking or communicating that complexity, but also enabling better design outcomes through testing. And so we've kind of categorized our service offers in this area around 5 areas. One being engagement, the using the right tools, and I'm going to go and show some examples later, but also around portals, visualization portals, being able to access that information, and then testing and operating in simulated environments, and not forgetting the world of storytelling and being able to use the visualization technologies and techniques and methodologies to enable those complex messages to be heard by both technical and non-technical audiences. And lastly, extended reality, starting to think about our sixth sense and starting to think about the digital world beyond, and what does that mean, and the advancement of technologies, and how do we start to accelerate those innovative areas in emergent technologies to them being applied and used in the built environment, so we actually have them as day-to-day lives. And I think it's something which I'm particularly conscious of as all these digital technologies start to take over us. Can we make them to enable us to have better environments to work and play, to be have contributions in environments in the urban realm, rather than being intrusive. So it's a big future topic around that subject area. So really just highlighting some of the skills we have needed to kind of bring together to fulfill some of those offers and areas. And there's the physical, digital kind of examples, which I'm going to talk about, how we start to think about projection technologies and ways to present data, but also a lot of the skills around understanding data, translating that data, but also the creative aspects to that through the narratives of visualization techniques. So we've kind of categorized these into 4 areas. One being about the research and understanding the user needs and principles. Another around kind of the advanced visualization and using all the plethora of different methodologies available, learning from other industries. And I find it particularly interesting, collective here today from different types of industries, all starting to be interested or have historically been interested in the same kind of ways of using these technologies and data. And then the experience design. I thought it was fantastic to hear Evan's previous presentation around understanding the users and analyzing that and having quantified outcomes from that. So we're not just looking at presentation, there's analysis, and having that loop to start to think about generative design, how we can start to optimize experience for all. And then starting to think about how we can use all the technologies, the cloud-based technologies, and all the other aspects of capitalizing the power of new areas of compute. Around the topic of digital engagement, it's complex. It's understanding projects right at the beginning, a line in the drawing in sand, articulating that vision, that ambition to enable that to happen at a very early stage. But as that project becomes more and more complex, we need to articulate it in different ways to different stakeholders, whether it's governmental or stakeholders in the community, and everything in between, design parties, technical design folk from different disciplines, to getting that holistic understanding. And so not one size fits all. And we understand that actually using the right capabilities of bringing that complex data together, but using the tool sets to present that data is really, really important. And I'll explain some of these shortly. So in terms of our facilities, we've got something called a sound lab offer, which we've developed over the last 20 years, and that's stationed in all our key offices around the world. It was kind of originated from our acoustic engineering expertise, but around venue consulting. But it became more increasingly used around environmental work, certainly around noise mitigation, around infrastructure projects like high-speed rail or aviation. Very, very influential. You know, the complex world of what do decibels mean, and being able to articulate that through ambisonic recordings, and wave synthesis, you're able to really take somebody to that location to really understand objectively, what does it mean to me? The other areas I'll talk a little bit around our simulation theatre, where it's more about room scale VR. So we're having collaborative experiences where we start to think about operational environments and using these spaces to collaborate, design, have sprints, make those decisions. And then in terms of engagement, we've deployed these things we call mobile studios around taking VR to communities, around difficult subjects to understand, certainly around aviation and the impact associated with that. So this little video talks about the iLab, which we've worked with Antisip in regards to the projection capability, but we brought together our acoustic expertise around having a number of speakers around in the environment. I think it's 24, and then having stereo projection to enable that to be understood for the users being inside the space. And it's also got motion capture, so we can start to track the individual in that space as well. So we can have those kind of areas where we can present those ideas, both city scale and one-to-one scale. I'll leave this video going. So you can see there's projectors here. We've got the motion tracking. Now this facility we're actually making bigger now in our new office, which we're developing. And so in a couple of months' time, it's currently being moved from our old office. So it's really exciting. We're all looking forward to kind of getting to work in this environment and engaging with people once again. And you can see this is film footage where we're using data visualization techniques to translate complex master plans to understand information from all those different areas of functions of buildings and environments. So when you go into the iLab, you can go in there. This is a colleague, Naomi, and going into the space. And an example here is looking at our venues and concert halls and being able to go and experience what that concert hall may feel like, and being able to hear that very, very accurately, and being able to test different concert hall designs and walk and understand the viewing corridors or the rakes of the seats, etc. And all that can be tested and optimized and consulted with different design parties in that space. So you can see here the tracking, following, and it's really particularly interesting when you go into the design environment, you suddenly understand the value of having the function of the facility by being able to test that design. And a very, very different experience to VR, which has it in terms of head-mounted displays, which has its merits. Having a shared space where you can go in together, I think really has its merit. And here you can see around data visualization and interaction design. So some of those are the key skills which are needed to being able to see that data and interact with it and interrogate it and collectively look at that together and understand it with others. Now that's key. And the kind of the next steps now is starting to think, we have this dedicated space. How do we bring others into that space? And now this kind of flexible working environment. Mentioned about the sound booths. This is the work we work with Heathrow on around consultation and engagement with communities. And you can see here being able to choose different airplanes, future flight paths, and testing those future propositions in different environments. So people could really understand in photorealistically where they are and what the future decibels may be. And we took this to every consultation around the whole the expansion at the time. Which was a kind of very technical way of delivering it, but it really gave confidence to people that whether it would be good or bad, they really understand, and being able to give them the tools to be able to have an active debate whether they're for it or against it. You can see some pictures of here being used in that environment. So we've all kind of experienced this world of lockdown, and so starting to think about how we can bring these tools so we can both remotely use them from our homes, but also collaborate and use in the office. And so this is work we've been doing around a platform we've been developing called Immersity, and it's a cloud-based visualization platform which allows you to understand context and design propositions. Now, I don't know if you've got sound, where the sound of the computer comes through, but it's got some funky sound. But you can see we're able to play this back in the iLab. But really, it's all about context and using the latest in reality capture or photogrammetry. We can then see from kind of an aerial contextual view to see planning propositions and the designs and viewing corridors in an objective manner. But also, we can start to use 360 cameras, LiDAR scanning, and photogrammetry from the ground, so we can see really articulated views from that really accurate perspective. And then through networked serious gaming technologies, we can collectively go into that environment and be in the same space through seeing avatars, being able to have that active discussion at looking at the schemes at those different levels of fidelity. So in the topic of simulation and operational simulation, I'm just going to talk a little bit about a case study around rail we've done here, and using a lot of the data, the complex data around consents and at different milestones of the project, but then to understand what it means from a user's point of view, a passenger experience simulation. And then you start to think about, well, we can test the whole experience, that one-to-one experience of waking up in the morning. How do you get to the station? How do you operate in the station itself? How do you fulfill all your different needs from different users? And then getting on the rolling stock, understanding the rolling stock design, the options and design areas around there, and then leading on to the kind of the views and the understanding of the mitigation and the consented scheme. And you can see here, we create visualizations of this complex route of the data set in the backdrop of route from an air. But really, the opportunity now is thinking from a design point of view, what does that mean? What does that really mean for the next hundreds of years of experiencing it? So the work we do around of creating that data, we're a lot about the visual impact of what the scheme might mean to people from afar, from the communities, the visual impact. And you see this video here shows bringing that complex information together across all parties, from architects to engineers to landscape designers, and many more. And then you're able to articulate and visualize what that means, and take that into our sound lab and hear the noise of the mitigation of different levels of sound barriers and vegetation. So you really can test those designs. But then when we have that information, we can also start to think from a passenger experience. So we created a virtual train simulation. So we had a physical, which was the kind of the mock-up of a train, and then the digital overlay of that experience at a photorealistic level, and traveling along that railway together in a networked environment. Incredibly powerful and influential in making people understand together what that future it is. And we brought in a motion platform from our advanced technology and research team to understand about the vertical acceleration and the acoustics, and bringing the acoustics, and then started to experience what it means to be in a station and gate lines and etc. etc. So many questions from different people come about. And here is a picture of it being used with a design panel to understand and critique the scheme in engagement with schools, roadshows, and future budding engineers and designers, but also rolling stock design, and then starting to use machine learning to analyze and quantify the experience. Here's some film of it in our room scale VR setup, which is essentially one part of our office where we've combined acoustics, motion capture, and head-mounted displays, etc. So we can start to test those environments. So here you can see different people kind of experiencing it, designing train seats, etc. And lots of different stakeholders coming in, but also remotely accessing site. So we're going here on a route map in VR. We're going to scenarios. We can see the before and after of the train. We can analyze that experience through analysis of what they're looking at, and categorization and galvanic responses, etc. And then using gaming technologies have that photorealistic experience of being on that system. So really exciting to see how these technologies, approach, and facilities bring together so many different people from which typically, historically, sometimes could be a siloed environment, but that holistic way of working gets great traction. So yeah, well, thank you for that. I hope it was all clearly came through clearly on microphones, etc.
Thank you very much, David. It just really fantastic to see, you know, some of your projects and what you guys are doing there, and great to see how ARUP have successfully woven immersive VR technologies into your projects, and your audio capabilities are equally amazing to see how they complement that as well. Our final presenter today will be Chris Woolart from BARCO, and Chris will provide us with an insight on how VR technologies have evolved to fit the changing demands of the AEC requirements, leading up to modern displays that can offer group VR experiences. And he'll provide us with a few highlights of the technologies that are evolving further with our capabilities in this area. So Chris, over to you, sir.
Thank you, John. Thank you. Hello, everybody. I'm Chris. I'm currently a product manager at a company called BARCO. Maybe you don't know the company BARCO. BARCO is a manufacturer that was founded about 80 years ago, a manufacturer of visualization and image processing solutions to enable bright outcomes in three different big market segments: the entertainment industry, where cinema, for instance, is a big part of it, but also in the enterprise industry and in the healthcare domain. Since about, I think, 25 years, BARCO has also been focusing on delivering visualization solutions for virtual reality and simulation. In the next couple of slides, I want to guide you a little bit through the use cases of adapting VR solution, VR technology for the architecture, engineering, and construction market segment, and also what kind of solutions are available on the market today. Let's go to the next slide. Okay, let me first start with maybe an obvious but reason where VR brings value in the chain for architecture, engineering, and construction, and that's the sales and marketing purposes. The objective of using VR tools, visualization, digital tools, is to illustrate the vision of the creator of a building, of a big project, of city planning. So illustrating your vision to the people that need to know your vision, to your potential customers, is an important part, of course, of selling your project. And VR technology brings added value towards customers that try to understand what you're trying to sell them as a story, what your vision is, what you bring to these customers. It enables also to guide you through the sales process, show your competitive advantages, upsell where possible, and especially also engage the stakeholders and make sure that the stakeholders are with you, with the story, with your vision, so that they are not disappointed afterwards about your vision, that they clearly know. So the results that we see there is that it helps you to shorten sales cycles, because by getting in depth into the virtual environment, people understand more the 3D depth perception, the scale of a certain design, and it enables you to go to shorter sales cycles, and as such do more sales, of course, and shorten your decision time. But also, and then importantly also, it enables also to have a better expectation management, because people that are buying your dream, you don't want to disappoint them afterwards. So a couple of pictures here in this slide showing some of the group VR solutions that are available today that are used for sales and marketing purposes. One of the pictures is for instance taken with a manufacturer of aluminium profiles in the industry for windows, for doors, and so on, and they use it to engage not only their end users or customers, but also the complete ecosystem, the architects around it, the other engineering companies, and so on. So sales and marketing is one of the use cases where VR can bring value. A second one that can bring value, and that translates a lot to the speakers before me, that was for research and engineering. VR and simulation can help you to simulate difficult, expensive, or dangerous situations. Some things that you cannot experience in real life upfront, or you do not want to experience upfront, you can simulate in a virtual environment. You can study the behavior of objects, but also you can study the human interaction in relation to the object. You can test designs before they are being built, and it allows you to go to a lot of different scenarios in a much shorter time than you want to test in real life. I'm just thinking on another domain where you also see this is used a lot is the autonomous driving scenarios that are now need to be tested. You can imagine if you have an autonomous car, you can test everything in real life, but there are so many dangerous situations that you don't want to create in real life. You want to create them upfront. Also in other industries like AEC, these kind of tests can help you to avoid a lot of dangers or unwanted situations, and importantly also predict human behavior on certain situations. So that's the research and engineering kind of domain where VR can bring value. A third one is what we call the project review and planning. So the stage after your property or your project has been sold, you now need to realize also there during your project planning and review, getting insight in 3D data with a lot of stakeholders, because typically you have a lot of stakeholders in the building process, getting insight and seeing it through 3D data allows you to come to better collaborative decisions. It's much more easier if people see it in real vision to come to a conclusion that people understand all the problems, and especially the different kind of stakeholders that may have different impacts and different views on things. It allows you to shorten the follow-up time, and also it allows you to make better decisions on how to solve potential problems or to avoid potential problems. And as such, will result in avoiding costly mistakes and a reduction of waste material. And at the end, the goal, I think, of every building construction company is also to do more projects on time and in budget. And there VR can bring value in the chain as well. And a fourth domain that I want to highlight is the training and education part. Training and education, you can do training in real life and on real things, but training in virtual reality gives you a number of benefits. Again, you can do a number of trainings on situations you don't want to, let's say you don't want to simulate in real life. That can be health safety training environments. It can be emergency staff trainings that you do upfront, even before things are built. But you can also train actual maintenance things upfront in order to avoid costs of sending people over, maybe offshore to an oil rig, or sending people over to another country, or fly them over to a certain specific installation where you want people to get trained on. So it allows you to grow the output also, that you have the throughput of the number of trainees in your system, going to cheaper training. It allows you to do more and hazardous kind of scenarios of training, easier to schedule and engage, of course, more trainees. So those are the four domains that we see where VR really can bring value to the AEC in industry. Now, in terms of visualization solutions, with the next slide, I've tried to kind of on one slide try to summarize what kind of visualization solutions, display solutions are on the market today, helping you to bring over your message in 3D. Most of you are probably aware of what is in the left bottom corner here is the headset. The headset is, let's say, the most obvious thing that people think about nowadays related to virtual reality. It's let's say, also in terms of stepping into virtual reality, probably the easiest way to step into virtual reality. If you look at the slide, I have tried to make a kind of 3 axes to kind of position all the different solutions. But I first want to focus on 2 segments. You see that on the left-hand side, I have 2 solutions, the headset and the 3D monitor. Which we call individual VR solutions. They are typically solutions that have been developed for an individual to do an individual assessment. On the right-hand side, we have Powerwall, the Canvas, and the Cave solutions, which are more collaborative group VR solutions. They have been designed to bring a couple or a number of people in front of to engage together into a virtual environment and to have a more smooth interaction in terms of body language, in terms of seeing each other, in terms of collaboration. So we call this the group VR solutions. In terms of investment, at the bottom side, you see we go from the left side, from the lower investment to the higher investment. But an important axis is also the left axis, where we define the multi-person, so the collaborative aspect, and the immersive experience. If you look at the headset, immersive experience, how do you get an immersive experience? Well, first of all, it's about filling your field of view as much as possible with the virtual environment. So the more you can fill your field of view with virtual environment, the more you're engaged into the content. A headset is very engaged, so you have typically the headset have a field of view of 120 to 150 degrees, but you can move around with your head, so you're in a 360-degree environment, fully embedded in the virtual world. There is no link to the real world anymore. On the other hand side, a 3D monitor, for instance, has a very limited field of view. If you look at the group VR solutions, there we position three types of solutions. The Powerwall, and the Powerwall you need to look at as a big single canvas, mostly flat, sometimes curved, but a big canvas, 6 meter, 10 meter, sometimes even more wide, where you can be in with a lot of people in front of, where you can engage. The canvas is a solution where you combine 3 screens and you put the screens under angle to get more field of view. So you are more immersive in a canvas solution compared to a Powerwall because your field of view is more filled with the solution. And then the most immersive group VR solution is the Cave solution. A Cave solution is combining all different sides, and it can go to a side in front of you, left, right, floor, ceiling, and even behind you. And if you have such a kind of caves environment, you have a 360-degree immersive environment again. I want to add also that immersiveness is also achieved in the group VR solution by adding 3D depth perspective by using stereo glasses. The stereo glasses that you may be using in 3D cinema in the past, these are the kind of glasses that are used in this environment to also introduce a next level of immersion, is depth perception. So you have your field of view, which is filled, and you have an extra depth perception. So that's a little bit how we overview the VR visualization solutions now today. And depending on your use case and budget, it could be either a good solution to use a headset, a Powerwall, or a Cave, or one of the other solutions. Just coming back a little bit on the difference between individual VR and group VR, and especially focusing when do you need what solution and what are the trade-offs to be made. First of all, on the immersive feeling, I already said the headset is fully immersed, whereas with the group VR solutions, typically you are partially immersed unless you go to a Cave type of solution with all sides projected, where you are also fully immersed. Collaboration, a very important aspect, of course, because these tools are in a lot of cases used to make decisions, and decisions are often made in group with a lot of people, with a lot of stakeholders. VR headsets are a single user solution. Of course, there are solutions where you can combine multiple headsets and with avatars come together in a virtual environment, but you miss the eye-to-eye contact, you miss the body language with each other. So it's a different kind of collaboration than you can have with a group VR solution, where you really see each other, where you collaborate intensively together. Ergonomics, also there, individual VR, the headsets, some people do not like them because they feel imprisoned, because there is some fatigue if you're using them a long time. It looks like a little bit intrusive, and sometimes people also do not feel comfortable because they lose the grip on reality. So you're fully immersed, which is good for one purpose, but sometimes people are scared because there is no reality anymore. There is no actual life or real reality anymore. Group VR you're using see-through glasses, so you still see each other, you still see the environment next to you, so people feel more comfortable there. In terms of location bound, whereas with individual VR you typically have more freedom where to do that. With group VR solutions, you see in a lot of cases they are at a fixed location. Sometimes they are transportable. There are group VR solutions available, such as transportable cave solutions, which are transportable, which are used, for instance, in exhibitions. But typically, in a lot of cases, they are location-bound fixed installations. And investment, whereas the headset is the lower investment, for group VR solutions, the investment is moderate to high, depending on your requirements for the solution. So that's a little bit the positioning about both. So as I already said, there is not one fits all here. It depends on your use case, and sometimes even a combination of both can help to fit your use case. Next, I want to go back a little bit on the history and the current situation of technologies for VR, because there has been a big, let's say, big evolution. And I want to first on the headsets. Headsets have become very popular since 2010, when big commercial companies like Oculus and HTC Vive came with commercial products, and as such, adoption for the mass audience for VR and headsets was there. But already in the 60s, there were kind of headsets used. The Telesphere mask, which was a kind of headset with small CRT tubes in it, was already there. Then you had, if you look at the lower picture, sometimes referred to as the sword of Damocles. That was the first VR head-mounted display that was connected to a computer, done by Ivan Sutherland, by the way. But it was a very heavy thing. You even needed to have a construction to hold the weight on top of your head, because your head could not capture or the full weight of the headset on your head. So the technology is not new, but it has been rapidly evolving. If you look at group VR, let's say stereoscopy was there around 1980s. You have the first 3D stereoscopic projector with CRT tubes in the 1980s, and BARCO was on the market already there with solutions. But in the 1990s, where BARCO started to focus also on delivering VR systems, virtual reality display systems, it was mainly a combination of CRT projectors that could do 3D stereoscopic and kind of big rigid screens. And typically these rigid screens were quite bulky, quite complex to install. So a complex process and bulky installations, because the CRT projectors needed a lot of space to project on surfaces. And if you look then on the computer software and application side, there in the 80s, 90s, there were solutions, but they were expensive. They were typically bespoke, very unique. I've put here some pictures of the image generators at that time, that probably with now one powerful workstation, you could now replace probably a battery of these big Onyx IGs from the past, which were part of SGI at that part. So the solutions were available, but there has been an evolution. If you look nowadays, headsets have evolved immensively. They are more comfortable in the past. The performance has gone up, and also there you need to distinguish between the commercial headsets, which are the, let's say, the below €1,000 kind of headsets that you find frequently, but there are also much more professional headsets with better resolution, higher performance, lower latencies, that can go up to a couple of €1,000 in terms of expense. But a lot of let's say a lot of evolution on that one, and still evolution to expect there, also both on latency, field of view, resolution, tracking kind of systems, still to come. If you look at group VR solutions, which are in the past typically based on purely projection, now you see a combination already of projection, but also direct LED view. So direct LED solutions are coming onto the market, and so an evolution there, also an evolution on the projector side. Nowadays, I think most projectors, let's say most professional projectors, make use not of light bulbs or CRTs anymore, but of laser systems, laser light systems. They have the benefit of long lifetime, ease of mind. You can use them many years without any problems. They have beautiful colors. So it's a much, let's say, comfortable solution, and also a better investment now, because your investment will last for a long time. Secondly, in terms of footprint, these systems have become more compact because you have now lenses on these projectors which are ultra short throw, allowing you to make systems much more compact. And then on the screen sides, in the meantime, we have developed innovative new screen technologies based on screens that you can roll up and that are easy to transport. So a lot of evolution there. And then last but not least, also on the computer side, I'm referring now to NVIDIA with their graphic cards and the evolution there, but also the processing side of computers. You know, they have been much more performant than in the past, but also the whole ecosystem around software, and how traditional companies like Nemetschek, also Autodesk companies or Dassault systems are now focusing on getting virtual reality into the workflow, in the software workflow, enabling to use virtual reality tools much more easier in the building process, in the design process, and embedding this in their software platforms. An important aspect there also is that game engines such as Unreal and Unity, which has been focusing mainly on the gaming industry until about 5, 6, maybe a little bit longer time, they are focusing a lot now on the enterprise industry, and they bring a lot of solutions and added value to the market that enhance the visualization, where you can very actively now also in your visualization change all the aspects of your project, being materials, being colors, whatever, in a very interactive way and much more easily than in the past. So a lot of evolutions on all the different domains. Important. A last thing that I want to stop here is that also on the collaboration side, which I already emphasized, these tools are used in a lot of collaborative solutions. So collaboration is also a focus for many industry software companies to make sure that these tools can be used collaborative-wise, either by using avatars in a virtual environment when people are using individual VR as a visualization tool, or other solutions where in group VR solutions you can collaboratively work together, but also combined solutions where in real time you can have somebody using a headset in Australia and working together with a group of people that are in a cave in Europe or in the US, interactively working together in the same project in real time, exchanging IDs with avatars and so on in the same environment. So very important there. And I want to conclude here because I think we are running over time as well. So that concludes my part. Up to you, John, now.
Thanks very much for that, Chris. And it's always quite nice to sort of reflect back on that sort of journey we've come from those CRT days to some of the wonderful and amazing technology that you guys are bringing to market today. At this point in the webinar, yes, we are running over a little bit, but we want to be able to open up for questions and answers. So I would ask all and encourage all the panelists, please to open your cameras and your microphones. We'll see if there's some questions coming in from the audience. And if you bear me 1 second, I'll just see if anyone's got any questions raised. So there's a question here for you, Chris. We want to know what do you believe is the latest technology that's emerging to make group VR even more collaborative than it is today?
Yeah, well, group VR solutions, if we refer to the cave type of solutions or the canvas or the Powerwall type of solutions, typically what you have and what is mentioned that during such collaborative session, there's one person which is tracked into the virtual environment, and the virtual environment is displayed based on the person that is tracked in this environment, and the people surrounding are having the same view, the same perspective as this single viewer. In the meantime, in terms of projection technology, there are now technologies available that allow you to have two persons with their individual perspective, both tracked and in the same virtual environment, so getting much more engaged. So you can already have kind of two groups of collaborative people joining each other, each with their own perspective, meaning that they can freely move in front of the VR display solution and have from their respective view the correct view on the virtual environment. That is a limitation that was in the past there, but with this new projector technology, which we often call multi-eye point kind of technology, this is now possible.
Thank you, Chris. And I think having experienced that technology, you know, it is you know, groundbreaking, I think, at the moment to make it more engaging and being able to see your colleagues' facial expressions and body language whilst you're both immersed in the same virtual environment. Just have a look for some more questions here. So a question for yourself, David. You showed the use of HMDs for some of your experiments. Has this been a challenge during the pandemic for people to utilize these devices?
It's a good question. Yes, I think you know, when we've kind of downed tools, essentially when we went all home, we changed our type of work we were doing by virtue of the types of things were in demand, and so we've looked at more online, web-based online gaming, network collaboration tool sets. So launching instances of gaming machines in the cloud and being able to see designs together remotely. But now we're looking at re-engagement of the office as things become more safe, and realize that it's a big draw, actually, the physicality of collaboration and experience. And one of the reasons why I'd like to think we all are going to be starting to have a bit of a hybrid approach to work, and actually having that physical digital connection is both creative and engaging and core to our business. In terms of ways of making it safe, we've been exploring ways to clean head-mounted displays, and looking at health risk assessments around using these technologies going forward.
Is that using UV to clean some of these
yeah, clean box
devices?
type technologies to do that, and then, you know, thinking about the types of audiences may engage. We won't be engaging with thousands of people kind of Excel in the immediate future, but it might be just very important decision makers to enable projects to happen. And in that spirit, we may be looking at you know, replacing, you know, some of the kind of contact elements to the headset as well. So it's thinking about the value, the impacts, and using the technologies in the right way in the current circumstances of this pandemic.
Okay, well, thank you very much. Irfan, a question for you. Does Bath University actively encourage third-party companies and organizations to collaborate with you and to use the V-Simulator facilities for their own research projects?
Oh, absolutely. So we are currently working with several universities and also with companies on research projects. And some of the examples that I mentioned are basically some of those projects that we are working with them. But we're definitely looking for partners, new ideas, collaboration, and absolutely that's the essence of this research. So by all means, absolutely.
Marvelous. Well, we are running a little bit over time, so I think we should probably conclude the Q&A session at this point. I want to thank all the guest speakers for being part of this event today, and if there are any questions that appear afterwards, we'll make sure we address those and document back some answers to anyone who's asked those. And I want to perhaps conclude by summarizing that it's very clear that large-scale group VR display systems are evolving, and we're moving forward with these technologies all the time, and I think they're becoming more and more immersive and more capable to support this advanced collaboration. And I think the appeal of these technologies is also growing in this AEC sector that we focused on today, and the quantifiable return on investment for those organizations who wish to embrace this future. So that's all we have time for today, but I'd like to say thank you very much to everyone involved, and thank you for watching.
Thank you, John. Take care,
Thanks, John.
everybody. Stay safe. Bye-bye.
Thanks very much.